So now we've seen the initial horizontal velocity and also the initial vertical velocity. What we're going to move on to now is horizontal motion, or otherwise you can think about it as horizontal displacement. So just how far an object has traveled, and then we'll do vertical motion and vertical displacement. We have our diagram here. So this is our angle of projection. That's the velocity, and this is a horizontal motion or displacement that we want to work out. Now, what you really need to know about the horizontal motion is that although when you throw something up and down, you think about it as getting slower and slower until here where it stops, and then it comes down and gets faster and faster. But that is actually in terms of your up and down, so your vertical. But your horizontal, just in terms of sheer distance that it travels horizontally, is actually completely steady. So the velocity along here is going to be exactly the same, which means that your acceleration will be 0. So that speed here, or velocity, doesn't change at all. It keeps going. And that means that, for example, if you were just lying on the ground and someone threw a ball over you, you would see that ball travel at exactly the same velocity the whole way through. Knowing that, then we can say the acceleration for your horizontal motion has to equal to 0, because it's neither getting any faster or slower. And then our velocity, we just use our initial velocity equation that we worked out before. But since I just said that your velocity is steady throughout, that means that we can also use that to say the velocity throughout. It's exactly the same velocity throughout. And now finally, to work out the motion or the displacement, what we need to do is to integrate our velocity there. And so we're going to integrate v cos theta in terms of dt. Now, I know you're going to ask, why dt? There's x and y there, so why in terms of dt? Well, do you remember how I told you that our velocity was also written as dx on dt? And this is just a simplified symbol to write that. So this is why in terms of dt. The other way you can think about it as well is that whenever we write velocity, we write meters or etc. per second. So that per second means meters on per second, and that's in terms of time. So that's why we also need to integrate or differentiate, etc. in terms of dt. So I hope because I've explained that to you, you can always remember it's going to be in terms of dt there. Let's integrate that now. So because in terms of dt, it's going to become vt cos theta and always plus your constant. Now the other note is, well, why is that cos theta still cos theta? Shouldn't it be sine theta by now? Well, that's because it's not cos x or cos t. Cos theta is actually just a constant, right? It just happens to be a number, what it is. So just think about it as a number, such as 2 or 3. It doesn't matter. It's just a constant in that case. With our constant c there, we need to work out what it is. So we think to ourselves, initially, right at this point here, when time equals to 0, we know that the displacement is also 0 because it's starting off at the origin there. So therefore, when t equals 0, x equals to 0. Substituting that in, that becomes 0. This side becomes 0. So therefore, c also has to equal to 0. So therefore, our horizontal motion equation is vt cos theta, right? So, couple of things that you have to remember. Our horizontal motion is steady, unlike our vertical motion. So therefore, that means that our acceleration is going to be 0, and our initial velocity will represent the velocity for the whole way through. And we need to integrate in terms of dt because we remember that x dot is actually represents dx on dt. So that helps us remember that we have to integrate in terms of dt. Good. So now we've learned the basics. Let's practice using questions. So here in question 4, I want you to find the equation of the horizontal motion, so our horizontal displacement. We know that our angle of projection is 60 degrees there, and the velocity we've been told is 100. So firstly, always start off with your acceleration. Whenever you're writing out these questions in exams or even in practice, we always start off with that line there. So acceleration, velocity, displacement, like that. Acceleration equals 0, and the velocity, we use our initial horizontal velocity equation. So that's 100 times cos theta, which happens to be 60 degrees in this case. And cos 60 equals to half. So we know that the initial velocity equals to 50 meters per second. We want to integrate that, remember, in terms of dt. And that just becomes 50t plus c. And we need to work out what that constant is. So we think to ourselves, when t equals to 0, our displacement is also 0. And we substitute that in, and we get that c equals to 0. So therefore, our equation of the horizontal motion is just 50t. Pretty simple, but the main thing is when you do set this out, because it's as much about setting it out properly as about working out the correct answer, you do need to start off with your acceleration, then go into velocity, and from velocity, integrate that into your motion or displacement. I don't want you to just start off with this line, all right? Okay, let's have a look at this one now. So in question 5, we want to find the equation of this horizontal motion. And this is slightly different because in the previous one, we threw it like that and it made that motion. Whereas this one, if you can imagine, we're kind of just like throwing it off a cliff or something. So we're throwing it horizontally and seeing what it does. So that means that that angle here between that line and that motion is actually 0 degrees. It's between that line and this motion there is 0. I don't want you to think about it as that angle. We know that the angle of projection in this case is actually 0 degrees. We're just throwing it horizontally there. So our acceleration is 0. It's always going to be 0 for our horizontal motion. Our velocity is going to be 100 times cos 0 degrees, and that is just 1. So 100 times 1 gives us 100 meters per second. And now we want to integrate that. So that becomes 100t plus c. And we know that when t equals 0, x also equals 0. And substituting it in, we find out that c equals 0. So therefore, our equation of our horizontal motion is going to be 100t. So you can see the maths in itself is not that difficult, but what I definitely want you to remember is the motion for horizontal is steady. So acceleration is 0, and this is always going to be the same. And then for our displacement, we want to integrate in terms of dt. So if you remember those 3 things, all right, I'll be happy.